So yesterday you did some polynomial division with the long division style, where it looked a whole lot like real number division. We use the exact same algorithm, but just for polynomials. Synthetic division does the same thing, but it's for a specialized case. It's only when the divisor is a binomial, a linear binomial, I mean degree 1 binomial, that has a lead coefficient of 1, like this one does. Then and only then can we use synthetic division. Or I take that back. We can use synthetic division for any linear binomial, but then we'd have to make an adjustment. But most of the time, the lead coefficient is 1, and we can do it. Okay, so in this case, if x plus 4 equals 0, if that's a root, then x equal negative 4. Negative 4 is what we're going to use in the little box for synthetic division. We're going to skip out on all the x's and just look at the numerical parts, all the coefficients and constants. So the divisor is negative 4. We do that, we change the sign, x plus 4 to negative 4, because we're not going to subtract in that subtraction phase of the division. We're going to go ahead and add. That way you won't make any mistakes. So the dividend is 2x cubed, just use the coefficient, positive 9x squared, positive 1x, and negative 12 is the constant. Leave a little space and then draw a line. And the way synthetic division works is you just bring down that first coefficient, it's a 2, and then multiply that times the dividend. 2 times negative 4 is negative 8, put that result there. Then we add, 9 plus negative 8 is 1. Then multiply, that's negative 4. And then we add, 1 plus negative 4 is negative 3. Then we multiply, that's positive 12. Then we add 0. So what we just found is the quotient, okay? This is the quotient right here. Well, let's take that back. This is the quotient, and that's the remainder. So we can say that 2x cubed plus 9x squared plus x minus 12 divided by x plus 4 is equal to 2x squared plus 1x minus 3, and the remainder is 0. We always, when we divide a third degree by a first degree, the quotient will always be 1 degree less than the divisor. So we took a third degree and reduced it to a second degree. That's our quotient. In example number 2, I'm going ahead and set it up. I'll put the opposite of the constant of our divisor in the box. So I got a negative 2 ready to go. And then I put the coefficients of the dividend. So it's 1x to the fourth, negative 2x cubed, and there's no squared term. There's 0x squared in this problem. So make sure you put a place for the 0, the squared term. If there's any missing terms, represent it with a 0. And then the 13x and negative 6. So it's ready to go. Bring the first coefficient straight down, and then we just repeatedly multiply and add. When it multiply is negative 2, add is negative 4. Multiply is 8, add, that's 8. When I multiply, that's negative 16. When I add, that's negative 3. When I multiply is 6. When I add is 0. So the quotient is x cubed minus 4x squared plus 8x minus 3 with a remainder of 0. Now that remainder of 0, that remainder right there of 0 is an important thing. I mean, if 24 divided by 8 equal 3 with no remainder, then 8 times 3 equal 24. 8 and 3 would be factors of 24. So in polynomials, whenever we have a remainder of 0, then the divisor and the quotient are both factors. We can say x cubed minus 4x squared plus 8x minus 3 times x plus 2 to equal our dividend, what we started with. So it's a way, I mentioned a couple of days ago that using division is a way to come up with some obscure factoring. We just started factoring this by finding a divisor that has a remainder of 0. Example number 3, I'll put a positive 2 in the box. All of the terms are accounted for. We've got a 3, 2, 1, 0 degree monomials in that polynomial, so there's no missing term. So we can get started. Bring that first one down. 6 times 2 is 12. When I add is 7. 7 times 2 is 14. When I add is 16. 16 times 2 is 32. And when I add, I get 31. So this time the quotient is, well, it's a second degree. Because I started with a third degree and reduced it by 1. This would be 6x squared plus 7x to the first plus 16. And that 31 is the remainder. So that's 31 over x minus 2. Just like we did with the long division, we put the remainder over the divisor. 4, we've got a divisor that does not have a lead coefficient of 1. So we have to really be on our toes here. This is not normal. What would go in the box is not a negative 3, but let's see, 2x plus 3 equals 0, 2x equal negative 3, x equal negative 3 halves. That's what's going to have to go in this little box, negative 3 halves. And then the coefficients are 6, 7, 1, 1. And let's try that. Bring the 6 straight down. 6 times negative 3 halves. Well, we take half of it is 3 times negative 3 be negative 9. And when I add, it's negative 2. Half of negative 2 is negative 1 times negative 3 is positive 3. And add. Half of 4 is 2. 2 times negative 3 is negative 6. And I add, that's negative 5. Now, before I write the quotient, we have to alter that, okay, since this is not the when I divided by that, I had to alter it. So if I divided this 3 by 2 right here, I divide these quotients by 2, these coefficients, and I get, it's divided by 2, I had to get 3x squared minus 1x plus 2. But the remainder is the same, a negative 5 over 2x minus 3, or 2x plus 3. That's how we compensate for having a lead coefficient that is not 1. Let's see if we can do the same thing on the next one. Okay, so we would say 4x minus 7 equals 0. 4x equal positive 7, x equal positive 7/4. That's what's going to go here in the box. And the coefficients would be, let's see, a positive 8, a positive 2. I got to put a 0 for the x term, x to the first, and then minus 48. And let's do our multiplication and adding. 8 times 7/4. Well, 8 divided by 4 is 2. 2 times 7 is 14. When I add, that's 16. 16 divided by 4 is 4. 4 times 7 is 28. And I add, that's 28. 28 divided by 4 is 7. 7 times 7 is 49. And when I add, that's 1. That's the remainder. Now, what is the compensation step we do? How do we alter these coefficients to be what the actual quotient is? Since we divided this negative 7 by 4, we're going to divide all of these coefficients by 4. And end up with an answer of 2x squared plus 4x plus 7, and the remainder remains 1 over 4x minus 7. That's it. 6 is a little of a twist. It says determine k, or the linear coefficient. What is k if x minus 2 is a factor? Well, if x minus 2 is a factor, then if we divided this divided by x minus 2, then the remainder would be 0. So let's do the quick division, the synthetic. We'll put a positive 2 in the box, put the coefficients 1, negative 2, got a 0x squared, got a kx to the first, and a positive 6. And do the division. 1 times 2 is 2, that's 0. 0 times 2 is 0, that's 0. 0 times 2 is 0, that's k. K times 2 is 2k. And when I add them, I get 2k plus 6. And for this to equal 0 would mean that when that remainder is 0, that means x minus 2 is a factor. So we just solve that. 2k equal negative 6, k equal negative 3. If k were negative 3, then x minus 2 would be a factor. 7 is a similar question. We got a couple of k's, but this time we don't want to know what if k minus 2 is a factor. We want to know what k would be if the remainder is 5. So instead of setting equal to 0 like we did here, we would just set that remainder statement equal to 5. We put the 2 in the box, put the coefficients, and ready to go. 1 times 2 is 2. When I add, that's k plus 2. When I multiply, that's 2k plus 4. When I add, that's k plus 4. When I multiply, that's 2k plus 8. When I add, that's 2k plus 9. And it says, what would k be in order for this remainder expression right here to equal 5? So we solve that. 2k equal negative 4, k equal negative 2. K would have to equal negative 2 for the remainder to be 5. I'm going to use synthetic division to show that the difference of two perfect cubes factors as a binomial times a trinomial in the form that we're used to seeing. But how can you use that? Okay, that means that if we divided this by this, this should be our quotient. So that the divisor times the quotient with a remainder of 0 would equal the dividend. In the box, we've got the coefficients of that is 1x cubed, 0x squared, 0x to the first, and negative 27. Let's do that dividing. 1 times 3 is 3. When I add is 3. 3 times 3 is 9. Adding is 9. 9 times 3 is 27. We add is 0. So the remainder is 0. And the quotient is x squared plus 3x plus 9. So the quotient times the divisor is equal to the dividend. We just proved it. And the remainder, when you divide this polynomial by this linear binomial, it's set up perfectly for synthetic division. We've got a linear binomial with a lead coefficient of 1. Put the opposite of the constant in the box. Put the coefficients 1, negative 14, 51, negative 54. And then start multiplying and adding. Negative 2, negative 16. 32, what's that, 83. Negative 166. Negative, what is that, 220. Negative 220. The quotient then is x squared minus 16x plus 83. The remainder is negative 220. In this jewelry box, the volume, remember that volume is length times width times height. If the height is x plus 5, find the other two dimensions. Okay, what is the length and what is the width? Well, we have a volume. We can plug this in for V, that's the volume. And we can plug this in for H. In other words, if we divide the volume by the height, we divide both sides by H, our result, our quotient, would be length times width. And then we'll go from there. Process of dividing the volume by the height in synthetic form. 1 times negative 5 is negative 5. We add, that's 2. Multiply is negative 10. Add negative 48 times negative 5 is positive 240. The remainder is big 0. So the length times the width, okay, divided by height over here, the length times width is a result. The quotient is the length times width. It is x squared plus 2x minus 48. Now we can factor that. We don't need to do any more dividing. That factors as x, probably plus 8 minus 6. So the length, I guess the longer dimension there, the length is the x plus 8, and the width would be the x minus 6. X plus 8, x minus 6. Part B, if the box is 15 inches high, what are the other dimensions? Well, we just take that x plus 5. That means x equal 10. So the length would be 10 plus 8 equal 18 inches. And the width would be 10 minus 6 equal 4 inches. That's today's lesson. Synthetic division. You can use it to factor. You can use it to solve other type problems. If you have any questions, I'll see you tomorrow, but you can get started on the assignment now.